Let's talk about the difference between compounds and mixtures. Compounds are a homogeneous form of matter whose composition of elements and products are fixed. For example, we have water, which looks homogeneous, and to generate water you need 2 moles of hydrogen and 1 mole of oxygen for every 2 moles of water. The elements here, hydrogen and oxygen, must undergo a chemical change to generate water, and the properties of water differ from that of oxygen or hydrogen. Furthermore, the components cannot be separated by using physical techniques like distillation or filtration. Only chemical reactions like electrolysis, where you break the bonds of water to generate back the hydrogen and oxygen, can be used to get back to the original elements. On the other hand, mixtures are composed of variable proportions of molecules and atoms. They are physically mixed, which means that their components retain their properties and only intimately interact with each other. Mixtures can be homogeneously mixed, like in the case of water and sugar, where if you add water to sugar and stir, then you get a homogeneous mixture, and if you add more sugar, your mixtures become sweeter. If you add more water, the mixture becomes less sweet. So water and sugar retain their individual properties. They only interact closely to each other, but they do not lose their properties. They can also heterogeneously mix, like in the case of water and oil, where the difference in density makes oil sit on top of the water. These mixtures can also be separated by physical techniques, unlike compounds. For example, water and sugar can be separated by distillation, where you can boil out the water and be left with the sugar. And water and oil can be separated easily because of the difference in density. You get out the oil and then the water. Let's look more closely into examples for homogeneous and heterogeneous mixtures. Homogeneous mixtures are also known as solutions. In the case of water and sugar, sugar dissolves into the water. Water is known as the solvent, which is the component of the solution with the larger amount. And sugar is known as the solute, which is the component that dissolves in the solvent. Other examples of homogeneous solutions include salt in water and a solution of copper sulfate in water. Heterogeneous mixtures, on the other hand, have components that can be differentiated with the unaided eye. For example, we can have water and sand, and when you put the sand inside the water, it just sinks at the bottom. So you can differentiate between the two, and the properties of the two are retained. Other examples of heterogeneous mixtures include milk and cereal, ice in water, and a salad of fruits and vegetables. We can also have homogeneous mixtures in 3 different states: solid, liquid, and gas. For the case of solid homogeneous mixtures, an example is brass, which is an alloy made out of copper and zinc. When you heat up the two metals, zinc diffuses into copper, forming a solid solution. And if you change the composition of copper and zinc, the phases in the alloy changes. So the composition is not fixed, unlike compounds. For the case of liquids, we have sugar and water, which we already discussed. And for the case of gas, we have air, which is a homogeneous mixture composed of nitrogen gas, oxygen gas, and carbon dioxide gas. Let's go over the different types of matter that we discussed in this lecture. First, we have pure substances that can be elements or compounds. Elements are the ones that we find in the periodic table, for example, helium. Compounds are made out of more than one type of atom. They have a constant composition, for example, water. Then we have mixtures that can be homogeneous or heterogeneous. Homogeneous mixtures, for example, sugar in water, have components that intimately and physically interact with each other. They look like one single entity. Heterogeneous mixtures have components that physically interact with each other, but they look like two different entities. For example, oil and water.